Alright, today you guys are going to learn about cylinders and cones. Now, they combine these into one section because they really are not new sets of rules that you guys need to memorize. You're going to see that these formulas come directly from the formulas for prisms and pyramids. Okay, so we start out talking about cylinders. So our definition just says it's similar to a prism except its bases are circles instead of polygons. There are really only two measurements you really need to know about in a cylinder. The radius, which is the radius of the circle, which is the base, and then the height of the cylinder itself. Okay? Now, Theorem 2.5 tells us the lateral area of a cylinder equals the circumference of a base times the height of the cylinder. So remember what our formula was for a prism? It was that lateral area equals perimeter times height. But remember, when we're talking about circles, we don't call it perimeter, we call it circumference times height. And then just to be more specific, circumference is this part right here, 2 pi r. So it's really not a new formula you guys need to remember. You go around the base and multiply it times the height, just like we did for a prism. Okay? Cylinders have two bases, so to get from our lateral area to our total area, it's that same formula. The total area is your lateral area plus 2 times the base area. The base is a circle, so we know the formula for area of a circle is pi r squared. So that's where that formula comes from. Now, for the volume, remember what it was when it was a prism. It was base area times height. Again, our base is a circle, so pi r squared is that formula that we're going to use every single time. It's actually easier because we don't have to worry about having different polygons as our bases. They're always going to be circles, so we're going to always use pi r squared to find that base area, and then just multiply it times the height of the cylinder. Okay, moving on to cones. Cones are going to work. All the formulas are going to come from the formulas for pyramids. Okay, they're very similar to pyramids, except instead of being a polygon, the base is a circle. So there are 3 measurements we're going to need in any cone to find our lateral area, total area, and volume. We need the radius, which is the radius of the circle, that's the base. The height, which is measured from the vertex of the cone straight down, forming a right angle. And then a slant height, which again is going to be abbreviated with the L, just like it was for the pyramids. Okay, let's learn our formulas for these cones. Okay, Theorem 7.2 tells us that the lateral area of a cone equals 1/2 the circumference of a base times the slant height. So remember, the formula that was for a pyramid, it was 1/2 PL. But again, we don't call it perimeter when it's a circle. We use circumference instead, which is where this 2 pi r comes from. Now, this can simplify, though, from the 1/2 times the 2, canceling each other out, it simplifies down to pi r l. Okay, so that's what I'm going to use when I work through our examples in a second. Okay, cones only have one base. So when we do it, their total area, it's just whatever the lateral area was, pi r l, plus 1 of the base areas. And again, the base is always a circle, so it's always going to be pi r squared. Okay, just like the volume of a cone, just like the volume of a pyramid was 1/3 the base area times the height, we can just be a little more specific with a cone because the base is always a circle, so it's always going to be 1/3 pi r squared h. Okay. All right, so let's use those formulas now to do example 1 and 2, finding A, the lateral area, B, the total area, and C, the volume. So first for our lateral area up here. Okay, for a cylinder, it's equal to circumference times the height, so 2 pi r, that's my circumference, times my height. I need to realize that this 16 is a diameter of a circle, meaning that the radius is going to be 8. So let's plug in 2 pi times my radius of 8 times my height of 21. And I get that my lateral area, that multiplies to 336, and we just leave the pi sign on our answer. Okay? Don't ever plug in for the pi unless you are specifically told to in your problem. We're just going to leave them in terms of pi. Okay? So that was part A, my lateral area. Let's do B, our total area. So a cylinder has 2 bases, so we know we're going to take our lateral area and add twice the base area to it for the top and the bottom of the cylinder to include them. So lateral area was 336 pi. Now I need to do 2 times pi times my radius. Remember, this is pi r squared in place of r b, so pi times 8 squared. So 336 pi plus, let's see what that multiplies to, 128 pi. Add those together. So our total area adds up to 464 pi. Okay, we just have C left, our volume. Okay, so volume is going to be equal to base area times our height. So we can be a little more specific because it's a circle. Pi r squared times our height. So pi times our radius 8 squared times our height of 21. So 64 times 21, that comes out as 1,344 pi for our volume. Okay? So that's how you work through for a cylinder. Let's take a look at our cone problem next in number 2. So 3, that's going to be my radius. 9, that's my slant height measured out there. I am missing the regular height. So our first thing we need to do is that's forming a nice right triangle for us. So let's set up our Pythagorean theorem. 8 squared plus 3 squared must come out equal to 9 squared, because the slant height is always the hypotenuse of that right triangle. So h squared plus 9 must equal 81. So h squared equals 72. Square root both sides. 72, that's 36 times 2. So h comes out as 6 rad 2. Okay, notice that wasn't one of the things I was asked to find here in the problem, but it is essential for me coming up with that volume. So I like to do it right at the beginning. Okay. Let's go ahead now and start finding the values they asked for. So lateral area for a cone has that special formula, 1/2 the circumference times L, simplifies down to just pi r L. So pi times my radius 3, my slant height is 9. So my lateral area is 27 pi. Again, just leave things in terms of pi, please. Okay, B, to find my total area. My cone just has one base, the bottom there, so I'm going to take the lateral area, the area of the sides, and just add on one base. Remember, our base is a circle, so we're going to use pi r squared to figure it out. So my lateral area was 27 pi, plus pi times my radius here is 3 squared. So that's going to be 9 pi plus my 27 pi. I get my total area must be 36 pi. Now all we have left is our volume. So for our volume, just like for a pyramid, it's 1/3 the base area times the height. So 1/3 of pi r squared h. So 1/3 pi times my radius 3 squared times my height 6 rad 2. When you multiply that out, you get 18 pi rad 2, and that's our volume.